Sheet molding and centrifugal casting are distinct composite manufacturing processes differing fundamentally in material form and the forces used for shaping. Sheet molding uses pressure to form solid sheets into complex parts, while centrifugal casting uses rotation to create hollow, cylindrical objects. This presentation compares sheet molding compound, also called SMC, with centrifugal casting of composites. High-strength composite manufacturing combines strong fibers, like carbon, aramid, with a matrix, polymer, metal, using methods like specialized methods like SMC and centrifugal casting besides layup, molding, RTM, compression, filament winding, and pultrusion to create lightweight materials with superior strength, stiffness, and fatigue resistance, crucial for aerospace, automotive, and other industries seeking enhanced performance and weight reduction. Processes control fiber orientation and distribution, often involving pre-pregs or injecting resin into fiber forms, followed by curing under heat and pressure to achieve desired properties. Sheet molding compound, SMC, is a composite material consisting of chopped fibers and a partially cured thermoset resin, supplied in a pliable sheet form. The process, usually involving compression molding, is ideal for medium to high volume production of intricate parts. Upper and lower mold halves are often heated. The SMC charge in the form of uncured sheet is placed in the mold halves. A press applies pressure. It can produce complex, three-dimensional solid parts for automotive panels and shower stalls. This diagram of sheet molding would illustrate a pre-cut section of SMC material placed into a heated, open, matched metal mold cavity. The mold is then closed under high pressure, causing the material to flow and fill the cavity before curing into the final, solid shape. Sheet molding allows high production rate with products having class A finish. Complex shaped products are easily manufactured through this technique. However, this process requires very high capital investment. Centrifugal casting, or rotocasting, produces hollow, rotationally symmetrical components by utilizing centrifugal force. Resin and reinforcement materials are introduced into a spinning mold. This method is popular for obtaining oxy-symmetric components like cylinders and rollers. A rotating mold, made up of metal, is common. Pouring mechanism and a drive system for rotation are essential steps in this process. Hollow, cylindrical or tubular parts, for example pipes, bearing bushes, street light poles, are commonly produced through centrifugal casting. This diagram of centrifugal casting shows a mold rotating at high speed, either horizontally or vertically. As material is poured in, the centrifugal force pushes it against the inner wall of the mold, where it solidifies under pressure to form a dense, uniform wall thickness around a hollow core. Main advantages of centrifugal casting include products with low porosity, high density, and good mechanical properties. This process is limited to cylindrical shapes only and has low production rate. Sheet molding compound, SMC, and centrifugal casting are two distinct manufacturing processes used for composites, differing significantly in their base material, part shape limitations, and production methods. SMC is a compression molding technique for various shapes, while centrifugal casting uses rotational forces primarily for cylindrical parts. A comparison is flashed on the screen. Sheet molding is used in automotive exterior panels, electrical housings, and appliance components. Centrifugal casting is used to produce composite pipes, chemical storage cylinders, and structural tubes. Sheet molding is ideal for high-volume production of complex shapes with high-quality surface finish. Cylindrical components having high structural integrity are manufactured through centrifugal casting. Stay tuned to get yourself acquainted to new topics in the field of composites manufacturing. Technology Education and Mentoring Center stands committed to its aim of popularizing the field of fiber-reinforced composites.